All right, today we're going to look at section 8.9, which is building in chapter 8 of the graphing that we've already learned how to do. And today we're going to look at solving a systems of equations through graphing. And what we're really finding is when two lines intersect, what's that one point that they have in common? All right, and we call that a system. A system of equations when we look at more than one equation at the same time. And we can look at any type of equation, but we're going to specifically look at linear equations. So we're going to find the point, right, the coordinate xy where two lines intersect. For example, right, if I have one of my lines that goes like this, and then I have another line that goes like this, okay, that's a system because there's more than one equation, and the solution is this one point, right, that has an x and a y, right, that one point of intersection. Okay, so that's the one point they have in common. Now, we're going to start off by looking at what types of solutions or how many are possible, right? If you have two straight lines, your possible solutions, you could have one solution, right? Meaning the two lines intersect, okay? You could have no solution, right? Where they do not intersect, right? And these are parallel. Or you could have infinite solutions, right? And this looks like just one equation, one line, but there's really two lines graphed on top of each other. And so it has an infinite because every single point on this line is the same in both. So that's why you have an infinite number of solutions. Okay, so that's what it looks like visually, but how does it happen? So in order to have one solution, your equations have to have different slopes. Okay, so if your equations have different slopes, they are guaranteed to intersect at some point. Okay, the only way to have no solution is when they have the same slope. Okay, they have to have the same slope, meaning they're increasing or decreasing at the same rate, so they'll never intersect, but they have to have different y-intercept, right? If they have the same slope and the same y-intercept, it would be the exact same line, which would give us infinite solutions. So infinite solutions have the same slope and the same y-intercept because they are essentially the exact same line. Now we're going to look at ways to solve, okay? And as you go into algebra, you'll look at other methods to solve, but in pre-algebra, we're just introducing the concept of system of equation and then the basic ways to solve, right? And one way is graphing, and then a little bit later on, we'll look at substitution. So when we graph to solve, we don't want to do it by hand because it's not very accurate, right? Meaning I should be able to sketch this graph based upon what we learned earlier in the chapter. Meaning I could say my intercept is at +1, which is right here, and I would go up to and over 1, and then I would draw my line. And then for this one, it starts at -2, and then it goes up 1, 2, 3 over 1. Right, and you can see I can barely draw a straight line. Okay, and this would be their point of intersection, but the problem is that when I graph like that, it's not very accurate. Okay, I'm not really sure what that is because I'm not to scale on my drawing. So we're going to look at Desmos.com. So I want you to pause your video here, and I want you to open up Desmos.com, Desmos.com, or click on the link in the agenda. All right, so if you go to Desmos, I want to type in y equals 2x minus 1. Is that right? 2x plus 1, excuse me. 2x plus 1. And y equals 3x minus 2. Let me just double check. Yep, 3x minus 2. So I just typed those equations in exactly like I saw, right? And I can look on here, and I know going in that they have different slopes, so they're guaranteed to intersect somewhere. So if I scroll my graph, I can see that they intersect right at this point. And if I hover over that, it's when x is 3 and y is 7. So my solution, oops, would be 3, 7. Okay, so when x is 3, y is 7, and that's in both equations. And you can check, right? I could say 7 for y, plug in 3 for x. 2 times 3 is 6 plus 1 is 7, so that one checks. See about here, 3 times 3 is 9, minus 2 is 7. That one checks. So this is my solution. It's the one point that both lines have in common. All right. So I want you to pause the video here and just get used to decimals. See if you can type these two in and find the solution. All right. And I'll do it with you as you're trying it. Y equals negative 1/4 x plus 2. Let me clear these ones out. Y equals negative 1/4. Now here's the thing. If I just hit x, okay, that's not the graph I want. It's putting the x on the bottom. I have to hit over and make sure my x goes here. So negative 1/4 x plus 2. All right, and I can scroll down to get a better picture. And then my other equation is y equals 3/4 x minus 2. Y equals 3/4 over x minus 2. Right? And if I hover over there, 4, 1 is my solution. So 4, 1. All right, and then last one, right? It's nice because we looked at different ways, meaning I could minus the 2x to the other side to get it in slope-intercept form. Or in decimals, which is nice, which most graphing calculators aren't like this. You can just type it in standard form, just like you see it. So 2x plus y equals 5. And y equals x minus 1. Y equals x minus 1. Right? Click on that point. Their intersection is at 2, 1. All right, now you still should be able to graph these equations, right? These linear equations using whatever method you prefer. But today, when we're solving for systems, we're going to use the decimals graphing calculator. All right, we said no solution, right? Which means the lines never intersect, right? So they have to be parallel. So if I look here, right, I can tell that's same slope, but they have different y-intercepts. That's going to give me no solution. And I can look 2x plus 2, y equals 2x plus 2, y equals 2x minus 3. Right? And I can see those are parallel. They're never going to intersect, right? So if you don't recognize it, you can graph. Okay, again, here's another example. Same slope of negative 1/2, different y-intercepts. They're going to be parallel. Now, here's one where when I look at it, they don't look the same, but I can't tell that the slope of this first line because it's not in slope-intercept form. So I could say minus 3x and get y by itself. So now both equations are y equals. I see that negative 3 is the slope, 4 is one of the intercepts, 8 is the other. So that is going to be no solution as well. Right? And then when you look on the calculator and you see the parallel lines, right, you could scroll back, you could scroll forward, they're never going to intersect. Now, for infinite solutions, right, you can see here, right, if we were to draw a sketch of this, right, let's start with the first one at positive 3. And then we would go up 1, over 4. There's my first line. All right, my second line, I start at positive 3. I go up 1 over 4. We get the exact same line, right? This would be infinite solutions, right? And you'll see this symbol used, right? The infinity symbol. That's another way to represent that. It's the same line, so every single point is going to be in common. There's an infinite number of solutions. Now, in this one, it doesn't look like they're the same. However, if I go to graph 2x plus 4y equals 4, so 2x plus 4y equals 4, and then my other equation was y equals negative 1/2 x, and then we have plus 1. Right, you can see it looks like the same line. So if I take this blue, if I click here, the blue comes off, back on. You can see it's the exact same line, right? And in order to compare lines, right, you have to have the same form. So just a quick refresh, 2x plus 4y equals 4. I can start by subtracting 2x from both sides, right? So I'd have 4y equals 4 minus 2x. Now, it's not y by itself yet, right? It's not y equals, so it's not slope-intercept until I divide. And I have to divide everything. So I get y equals 4 divided by 4 is 1. Negative 2 over 4 is negative 1/2 x. So I can see negative 1/2 for the slope, positive 1 for the y-intercept. Those are the same line, infinite number of solution. Now, solve by substitution, right? And we looked at substituting way back at the beginning of pre-algebra, right? And it's simply where we take the value of one variable and plug it in for the other. So if I look here, it tells me what y is equal to. So like if I'm going to solve this, I know that 3 is the solution for the y value. I'm trying to find where's the x, right? And think about this for a second. If I just do a quick sketch, y equals 3, right? There's no slope. It's a 0 slope, so it would be horizontal. And then if I graphed this one, I would start at negative 1, slope of positive 1, so up 1 over 1. I could do that, up 1 over 1, right, until I ran into that line. So this is going to be the x value when y equals 3, right? And I got to figure out what that is. So what we can do is we can use substitution. I already know what the value of y is. So I can simply take this value and plug it in and say 3 equals something minus 1. Right? I should know it's 4, but if I add 1, right, use inverse, so it looks like 4. Add 1 to both sides, we get 4 equals x. So the point 43 is my solution, right? And you could graph these as well, all right, but I want you to know another method. Right, so we had y equals x minus 1 and y equals 3. And if I hover, 4, 3 is my solution. All right, so graphing is always a method that works, but sometimes it's easier when it tells me what a value is to just substitute it in. So here would be y equals 3 times 4, right, because x is 4 in this case, minus 2. So I know that x is 4. I'm trying to find this y value. Well, 3 times 4 is 12, minus 2 is 10, so y equals 10. So 410 is the point that they have in common. All right, one more example here. Y is 6, so that goes in for y. So something plus 6 equals 8. If I subtract 6 from both sides, we get x equals 2. So x is 2 and y is 6, right? Write it as an ordered pair, right? X is 2, y is 6. So this is my solution to this system. All right, on 8-9, you're going to do the following problems, number 9 to 21, starting on page 417. If you have questions, stop down and see me. If you're in person, virtual, can give me an email. Hope you all have a great day, and we'll talk to you soon.